something else, the direction the wind's blowing. You never know, it could be. It depends. And so you could do linear regression like we did, or you can do multiple regression, which is you got multiple variables just like the linear regression. So let's see. They got linear here on home sales. Yeah, so here's your 30-year mortgage rate. Yeah, home sales. Then these are the columns they're using to calculate these. Again, I would not do these calculations. I would let Excel do it for me. And let's see. Yeah, so now they're forecasting what happens when 6% mortgage rate, you're going to get 898 home sales, 8% you get 701. Yeah. So it's instead of time, it's some other variable. Okay. Let's see. Multiple regression is you can have more than one independent variable. I've already shown you how to do that. Really, that's basically what I did, right? So now instead of y equals intercept plus the slope times x, it could be slope times x1, x2, x3, x4. As many independent variables as you want. Okay. So this is the politically insensitive example. It's on their view graphs. I didn't make it up. I wouldn't have made it up. So Lance's barbecue, he's gonna make a model for how much barbecue he sells, and he's tying it to number of customers, which is a good variable, and then the average weight of the customers. So yeah, no. Now I want to see how he gets this data. That's actually put little scales on the way in. When you're looking at a made-up problem that. Well, I hope. Because I don't know,
I hope he did.
I even involved there. I should look online and see if Lance really exists. But I wouldn't do it this way if it was my business. So Lance has a party coming up. He's got 60 guests, and thinks he's wait. So it's a football team, right? So it's going to use multiple regression to guess how much barbecue he's going to sell. So, and so I don't like this view graph because they didn't do anything, right? They just told you the answer. Now that's a big help. But I showed you how to do it, and I got another example too. So here's his two slopes, right? There's his intercept. So in my example, I had A, B, and C. I didn't have intercept, did I? But I had three slopes. I had one on A, one on B, one on C. So now here's his new model: the intercept plus the slope on the guess, the slope on the weight. Plugs in the number of guests he thinks he's going to have, how much they weigh, 57 pounds of barbecue. Good job, Lance. Let's see. Yeah, okay, yeah. So here's my other example for you. It's called example 4.3. The reason it's called example 4.3 is because I took it out of the design of experiments class, which is another class you'll have. So you can see you'll get this stuff again. So don't think that if you don't leave here understanding linear regression that life is bad. You'll see it again. It's coming up. This is still the core loss one. Life is bad. You'd be sad, wouldn't you? Okay, so what is this one? I wanted to show this one to you because, again, similar to this one, you may say, I don't have a line. I don't want a line. I don't like a line. I don't want my data to vary with the number of guests and how much they weigh. I want it to vary with the number of guests, how much they weigh, times how tall they are. Because maybe they're short and fat and don't eat much, but the tall, big guys really eat a lot. I don't know. I don't know. So look, here's that same thing, that same strange idea. I've got A, B, and C. Why don't we have A times B, A times C, B times C, A times B times C, A squared, B squared? What? You just go have a party, whatever you want. But why would you might do that? Well, maybe you don't know. And that's the whole point of design experiments. Maybe you think it's A times B, but you don't know because guess what? You've got lots of data and it's all over the map and you can't quite tell. And we'll get to that in design experiments, how you can make experiments and run these analyses and find out which ones they are. But the point is, geez, I could go all across the page with relationships, log of A, and I can have fun and still use linear regression. And so I've done that here just for fun. You can see how the simple regression, I only chose A, B, and C. And I didn't show you the equation on this one. Well, here, it's got it. So it's got an intercept, it's got a slope on the A, a slope on the B, and a slope on the C. Or I did a complex regression where I did them all. Look, A, B, C, A times B, A times C, B times C. And so you can look in there and you can kind of, you can kind of tell things too. Like, well, just from looking at this, you might make yourself a model that just used the biggest ones. Maybe that's the simplest thing to do. But be careful, because maybe the range of A is huge, and it goes to 1,000 and 1,000 times that. This only goes to 0.1, it's still bigger. You have to be careful. And there's ways to look at this information. It's, like I said, it's another class, to tell which ones are worthy of consideration and not. And then you can make your model from that. But this is the same approach when you do this. When I made this regression, I didn't do anything different than what I just already did. I selected these as my Y's and all of these guys as my X's and pushed a little button that said regression, and it was done. And so this is a nice tool, truly. Again, Excel is a better tool than it appears, I think. On the surface, everybody thinks, well, geez, Excel is just a place where I, write in my, something or other to put, make a table. It's extremely powerful, and statistically, now you run into things. You see, when we do the statistics class, it does almost everything we need to do. I can't think of anything in the first level statistics class it can't do. In the design of experiments, there were things it could not do, and so it does run into a brick wall there. And then you need to go to something like, some of these jump or SAS or some of these other better packages that cost you money. Man, our food's here. We'll do two more view graphs, and you can grab it. So I showed you a way to decide which of those four approaches were better with that Mr. Thiel's statistic. There are other statistics that you can use to look at the quality of your forecast, and that's what the next few view graphs are. So you got things like the forecast error. Gee, I would have never thought of that, right? Take my demand and subtract the forecast, and no, I've got an error. Yeah, oh, well, okay. Or how about averaging those? Yeah, okay, yeah, that's a good idea. Or how about, instead of looking at the average, because if I had a bunch of pluses and minuses, maybe the average is just come out to be 0, and I'm thinking I'm doing great, but I don't want to do that, right? Let's average the absolute value. That's a little bit better. Or a square root. That's why people do those kind of things. And just know, as long as you know the size of the number, who cares? If it's absolute value square, root of the square, or something like that, either way. So when you can see these acronyms, MAD, MFE, they're in the chapter, they're in the book. Two months from now, you probably won't remember them, but remember there's the key formulas in the back of the chapter, and you can always just look them up real quick. And then, gee, you can play around with it, right? You could make it a %. Oh, well, I wouldn't have thought of that either, right? These are, of course you can. And then a tracking signal is, if you will, the way I interpret this is sort of a cumulative error. Look, you're summing from 1 to n of each of your errors, and then you're dividing it by the mean error. So it's sort of as I'm going along, how am I getting off as an aggregate. And that's why they call it a tracking. How well am I tracking as I'm cruising along? Again, if I were going to use these on some sort of situation, I would build myself a little test model, either like that random one I gave you, the one that's got all the signals in it, or I would make me some data off something that's similar to what I've got, or just make some up. Either way, if I don't know, and test it and see how it works, get a feel for the magnitudes, get an idea. These are things you can do without having to delve into the deep mathematics of how these techniques are made. You just look at it, play with it. After a little bit of playing, you at least understand enough, I think, to apply to a situation, especially, if it's the central part of your capstone or some word. No, you want to dig into it. You want to spend the time to understand the mathematics. But if it's just something you're going to get an answer, a trend, use it, and go on to make broader, greater conclusions, okay, just use the tool and get on with it. You're not building a shovel, you're just digging a hole. That's the thing. And so why don't you grab your food, and we'll finish the last few view graphs after that, and I'll talk you know, during my lunchtime chat, let's see, which I'll bring up.